AI is here to stay, with the promise of transforming the way the world works. According to a study by PwC, $16 trillion of GDP will be added between now and 2030 on the basis of AI. This is a never-before-seen scale of economic impact, and it is not just in the IT industry. It impacts virtually every industry and aspect of our lives. AI means different things to different people. For a video game designer, AI means writing the code that affects how bots play and how the environment reacts to the player. For a screenwriter, AI means a character that acts like a human with some trope of computer features mixed in. For a data scientist, AI is a way of exploring and classifying data to meet specific goals. AI algorithms that learn by example are the reason we can talk to Watson, Alexa, Siri, Cortana, and Google Assistant, and they can talk back to us. The natural language processing and natural language generation capabilities of AI are not only enabling machines and humans to understand and interact with each other, but are creating new opportunities and new ways of doing business. Chatbots powered by natural language processing capabilities are being used in healthcare to question patients and run basic diagnoses like real doctors. In education, they are providing students with easy-to-learn conversational interfaces and on-demand online tutors. Customer service chatbots are improving customer experience by resolving queries on the spot and freeing up agents' time for conversations that add value. AI-powered advances in speech-to-text technology have made real-time transcription a reality. Advances in speech synthesis are the reason companies are using AI-powered voice to enhance customer experience and give their brand its unique voice. In the field of medicine, it's helping patients with Lou Gehrig's disease, for example, to regain their real voice in place of using a computerized voice. It is due to advances in AI that the field of computer vision has been able to surpass humans in tasks related to detecting and labeling objects. Computer vision is one of the reasons why cars can steer their way on streets and highways and avoid hitting obstacles. Computer vision algorithms detect facial features in images and compare them with databases of face profiles. This is what allows consumer devices to authenticate the identities of their owners through facial recognition, social media apps to detect and tag users, and law enforcement agencies to identify criminals in video feeds. Computer vision algorithms are helping automate tasks, such as detecting cancerous moles in skin images or finding symptoms in X-ray and MRI scan. AI is impacting the quality of our lives on a daily basis. There is AI in our Netflix queue, our navigation apps, keeping spam out of our inboxes, and reminding us of important events. AI is working behind the scenes, monitoring our investments, detecting fraudulent transactions, identifying credit card fraud, and preventing financial crimes. AI is impacting healthcare in significant ways by helping doctors arrive at more accurate preliminary diagnoses, reading medical imaging, finding appropriate clinical trials for patients. It is not just influencing patient outcomes, but also making operational processes less expensive. AI has the potential to access enormous amounts of information, imitate humans, even specific humans, make life-changing recommendations about health and finances, correlate data that may invade privacy, and much more.
Can you talk about some of the applications of AI?
There's all kinds of different applications, obviously. There's healthcare, there's finance. The one that's closest to my heart, of course, is robotics and automation, where the AI technologies really help us to improve our abilities to perceive the environment around the robot and to make plans in unpredictable environments as they're changing.
There's a great book out by an author who's Kevin Kelly, and he's an editor for the Wired magazine. He's written a great book about technologies that are going to be changing and shaping our world, specifically 12 technologies. And he's got a fantastic definition in the book about, specifically how AI is going to permeate our everyday lives. And it's all summarized in one excellent quote. So he says that the business cases for the next 10,000 startups are easy to predict. I have X, and I will add AI to my X. The way I understand that is, is basically a notion that AI in one shape, way, or form, in any shape, way, or form, is going to permeate every aspect of human endeavor. Everything we do, everything we touch is going to be enhanced by AI. We get great benefit from taking any device, any machine, and make it just a little bit smarter. The benefit of that is, just adding a bit of smarts to it, a bit of intelligence to it, is exponential in its benefit.
So we work a lot with some really fun applications of AI. We do a couple of different things in the lab that I run. We work on self-driving vehicles as one aspect, so autonomy for self-driving, which requires a lot of AI for the vision systems, for the navigational intelligence, for the planning and control aspects of the car. We do that, and we also have a large research program in what are called collaborative robotics, or cobots. So robots that are designed to work in and around and with people. And that presents a lot of challenges because we want the robots to act intelligently and to interface with humans in a way that is natural. And that requires understanding how people behave, which requires intelligence. In addition to those, there are a myriad of other applications, drug discovery, medical treatments for cancer and other diseases. So a bunch of extremely exciting applications.
I mean, I think the general use of AI so far has been taking large data sets and making sense of them, and doing some sort of processing with that data in real time. That's what we've been doing, and that's what we've seen most effective in terms of creating some sort of larger scale impact in healthcare beyond just having a siloed device. And we've been seeing that across the board, across the whole healthcare spectrum.
We use AI all the time, and a lot of the times we're not even aware with it. We use AI every time we type in a search query on a search engine, every time we use our GPS, or every time we use some kind of voice recognition system.
I'd like to focus on a particular segment of AI, if that's okay, around computer vision, because it's just particularly fascinating to me. Now, when we think of computer vision, so we're looking at AI in ways to help augment or to help automate or to help train computers to do something that's already very difficult to train humans to do. When it comes to the airport, trying to find weapons within luggage through the X-ray scanner, that could be difficult to do. No matter how much you train someone, that can be very difficult to identify. But with computer vision, it can help to automate, help to augment, help to flag certain X-ray images so that maybe even humans can just take a look at a filtered set of images, not all of the images, right? So computer vision is very disruptive. And so there's many ways in which computer vision can really help to augment the capabilities of humans in lots of different industries.
Now, I mean, applications of AI are really all around us. There's no limit to really what we're doing with artificial intelligence. When you do practically anything on any technology, you're most probably using some form of what we call machine learning or artificial intelligence. Like, for example, when you check your email, doing something as simple as checking your email. Spam filtering has been done for years with machine learning technology. More recently, Google came out with their features that enable you to do smart email composition, so you can actually have text written for you on the fly as you're writing your email. Your subjects are automatically written as well. It'll recommend to you who you should be sending the email to, see if you've missed someone. All of these things are powered by machine learning. But some of the main areas where I believe machine learning technology can make an impact are the fields of healthcare and education.
Can you give some specific examples of applications of AI?
Certainly. So we have a fairly large collaborative robotics program. And so the cobots we work on are primarily targeted at the moment at manufacturing applications, manufacturing, warehousing, logistics, these types of applications where normally you may have a person doing a job that is, it can be dull, it can be dangerous, and having robotic support or having a robot actually do the job may make it much safer, more efficient, and just more effective overall.
So we work on a lot of those types of applications, particularly where the robots are trying to interface directly with people, as I said. So the robot may help an individual to lift a heavy container or help to move items on a shelf for stocking purposes. So all these kinds of applications where I think we'll see collaborative robots move first, and then hopefully one day maybe into your home to help you with the laundry and the dishes in the kitchen, hopefully.
For example, in oil and gas, there's a company, a pretty large oil and gas company called the Abu Dhabi National Oil Company. And what they do is, well, I should say, one of the problems that any kind of oil company has to deal with is, where is the best place for them to drill for oil, right? So they have to find these rock samples of all these different places, from this place and then this place and that place, and maybe hundreds of different places for them to drill oil. And from these rock samples, now you have all these, fine sheets of rock, and maybe hundreds or thousands of them. And it's up to these oil companies to be able to, classify these using their trained and expert geologists. But to train geologists to properly classify these sheets of rock can be quite difficult. It could be time-consuming, could cost a lot of money as well. So one way to help augment the capabilities of humans is to be able to use computer vision to classify these, rock samples, to be able to identify which of these locations are the best to drill for oil. And that's in oil and gas.
Imagine before this, if there was a very, very rare form of cancer experienced by a doctor in Dubai, and if there were another case in New Zealand, how do you think they would have actually figured out that, hey, we're both dealing with this very rare case, let's work together? That wouldn't have been possible in the past. But now with machine learning technology, being able to aggregate knowledge from so many different sources into one centralized cloud and understand it and provide that information in an accessible, intuitive, implicit way, now that New Zealand doctor can actually go ahead and use this machine learning technique to say, hey, just a few days ago there was a doctor with a very similar case, even though it may not be the exact same thing.
Sure. So we work with a number of startups and a number of enterprises, and I'll just bring a couple of examples. So one that I like to talk quite a bit about is a company out in California called Echo Devices. And what they've done is they've taken a simple device, which is stethoscope, something we see around the neck of every physician, a nurse, and healthcare professional. And they've taken that device and they've basically have transformed it into a digital device by cutting the tube on a stethoscope, inserting a digitizer into it that takes an analog sound, transforms it into a digital signal, amplifies it in the process, makes it a lot easier for people to hear, because it's amplified sound, the sound of your heart or your lungs working. But what it also allows us to do is it allows us to take that digital signal and send it via Bluetooth to a smartphone. And once it's on a smartphone, they're able to graph it, which allows the physician to better understand, not just through audio data, but through an actual graph of how your heart is working. But because that information is now captured in the digital world, it can now be sent to a machine learning algorithm, and that's what they do. And a machine learning algorithm can actually now learn from that, apply a previous learnings from the human doctors, cardiologist, and now assist a physician who is using the device in their current diagnosis. So this is, it basically, it's not replacing a physician in any way, shape, or form. It is assistive technology, which is taking the learnings of the previous generations of the humans, human cardiologists, and helping in the diagnosis in the current state. To me, that's a perfect example of taking the X, which is in this particular case is the stethoscope, and then adding AI to that X. And they have a really nifty name for that. They call it Shazam for heartbeats.
Can you talk about AI in action?
To give an example of, say, machine learning in action today, how companies have actually implemented it, there's one example that I always love to go back to, and it is the example of Woodside Energy, a company in the Australia-New Zealand region. Now, originally, they actually contacted IBM because they wanted IBM to be able to create essentially a system that can understand the different documents and the research that their engineers come up with, and have Watson understand that and essentially replace some of the engineers on their team. And, IBM actually went ahead and built the application. It worked. Watson was able to understand that unstructured content, but they never ended up replacing any of their engineers. Instead, they actually ended up hiring more engineers because now they realized that two things. First of all, the barrier of entry for each engineer is now lower, and knowledge can now be shared more effectively among the teams. Because now, instead of research being written and put into an archive drawer where it's never seen again, Watson's ingesting that data, understanding it, and providing it to whoever needs it, or whoever Watson thinks would need that data.
So if you imagine, in these TV shows and in these movie scenes as well, you have, sometimes, someone's looking for a particular suspect in this particular, traffic intersection or whatnot. They've passed through this intersection, and there's, of course, some cameras around. And so we have the security guard, maybe, try to look through hours and hours, dozens and hundreds of hours of footage, maybe at 10x speed, and trying to find that particular black SUV or that green, car. And then as soon as they find it, at the end of the episode or whatnot, then they say, aha, we found that person. But if you had some sort of computer vision algorithm running on this video footage the entire time, then you wouldn't have a need for, some person to have to manually watch through hours and hours of footage.
Our specific use case is actually triggering new neural pathways in the brain to form. As you can imagine, there's a lot of information that happens there between the connection of how your body functions and how your brain functions, and what parts of the brain are damaged, what parts of the brain aren't damaged, and how you're actually moving the person, or how you're triggering certain things in the human body to happen in order for new neural pathways to form. So what we've done is actually we've created massive data sets of information of how people move and how that responds to different areas of the brain. And through that information, we're able to trigger specific movements with a robotic device, which in turn creates these neural pathways to form in the brain, and therefore recovering the person who's suffered a neurological trauma.
I remember that morning going to the lab, and I was thinking, this is it. This is the last Jeopardy game.
It became real to me when the music played and Johnny Gilbert said, from IBM Research in Yorktown Heights, New York, this is Jeopardy. And I just went...
And here it is, one day. This is the culmination of all this work. To be honest with you, I was emotional.
Watson.
What is issue?
You are right.
We actually took the lead. We were ahead of them, but then we started getting some questions wrong.
Watson.
What is leg?
No, I'm sorry, I can't accept that.
What is 1920s?
No.
What is chic?
No, sorry. Brad.
What is class?
Class, you got it. Watson.
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
The Double Jeopardy round of the first game, I thought was phenomenal.
Watson went on a tear.
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right, and with that, you move to $36,681. Now we come to Watson, who is Bram Stoker, and the wager? Hello, 17,973, and a two-day total of 77,147.
We won Jeopardy.
They're very justifiably proud of what they've done. I would have thought that technology like this was years away, but it's here now. I have the bruised ego to prove it.
I think we saw something important today.
Wow, wait a second. This is history.
The 60th Annual Grammy Awards, powered by IBM Watson.
There's a tremendous amount of unstructured data that we process on Grammy Sunday. Our partnership with the Recording Academy really is focused on helping them with some of their workflows for their digital production.
My content team is responsible not only for taking all of this raw stuff that's coming in, but curating it and publishing it. You're talking about 5 hours of red carpet coverage with 5,000 artists making that trip down the carpet with 100,000 photos being shot.
For the last 5 hours, Watson has been using AI to analyze the colors, patterns, and silhouettes of every single outfit that has passed through. So we've been able to see all the dominant styles and compare them to Grammy shows in the past.
And Watson's also analyzing the emotions of Grammy-nominated song lyrics over the last 60 years. Get this, it can actually identify the emotional themes in music and categorize them as joy, sadness, and everything else in between. It's very cool.
Fantasy sports are an incredibly important and fun way that we serve sports fans. Our fantasy games drive tremendous consumption across ESPN digital properties, and they drive tune-in to our events and studio shows. But our users have a lot of different ways they can spend their time. So we have to continuously improve our game so they choose to spend that time with us.
This year, ESPN teamed up with IBM to add a powerful new feature to their fantasy football platform.
Fantasy football generates a huge volume of content. Articles, blogs, videos, podcasts. We call it unstructured data, data that doesn't fit neatly into spreadsheets or databases. Watson was built to analyze that kind of information and turn it into usable insights.
We trained Watson on millions of fantasy football stories, blog posts, and videos. We taught it to develop a scoring range for thousands of players, their upsides and their downsides. And we taught it to estimate the chances a player will exceed their upside or fall below the downside. Watson even assesses a player's media buzz and their likelihood to play.
This is a big win for our fantasy football players. It's one more tool to help them decide which running back or QB to start each week. And it's a great complement to the award-winning analysts our fans rely on. As with any machine learning, the system gets smarter all the time. That means the insights are better, which means our users can make better decisions and have a better chance to win their matchup every week. The more successful our fantasy players are, the more time they'll spend with us.
The ESPN-IBM partnership is a great vehicle to demonstrate the power of enterprise-grade AI to millions of people. And it's not hard to see how the same technology applies to real life. There are thousands of business scenarios where you're assessing value and making trade-offs. This is what the future of decision-making is going to look like. Man and machine working together, assessing risk and reward, working through difficult decisions.
This is the same technology IBM uses to help doctors mine millions of pages of medical research. And investment banks find market-moving insights.
Welcome to Generative AI Applications. After watching this video, you'll be able to list various applications of generative AI and explore the uses for each application. Generative AI has emerged as a powerful technology that enables software applications to create, generate, and simulate new content, enhancing their capabilities and providing unique experiences. Unlike traditional software that follows predefined rules and algorithms, generative AI leverages machine learning and deep learning techniques to learn patterns and generate original content based on the knowledge it has acquired during training. Due to its potential to create new, personalized content that would have been impossible to create otherwise, generative AI has been used in various fields, leading to the development of numerous engaging and well-liked applications. Some popular applications of generative AI in action include 1. Generative Pre-trained Transformers, or GPT, is a family of large language models developed by OpenAI that are capable of producing human-like text. GPT 3.5 and GPT 4 are iterations in this family of models with more futuristic models under development. It has a wide range of applications, including chatbots powered by GPT, like ChatGPT, automated journalism, and even creative writing. 2. ChatGPT is a chatbot or conversational AI tool by OpenAI that enables users to have text-based conversations with the underlying language model, GPT. Trained on diverse internet text, it generates human-like responses, providing information, answering questions, assisting with tasks, engaging in creative writing, and offering suggestions across various subjects. 3. Bard is an AI-powered writing assistant from Google that aims to assist users in producing high-quality writing for communicational documents like emails and social media posts. Bard generates text using large language model called Lambda, language model for dialogue applications, and can adjust to the user's preferences for style and tone. 4. Watson X from IBM is an AI and data platform comprising watsonx.ai for model deployment, watsonx.data for scalable analytics, and watsonx.governance for responsible AI workflows. It helps build, deploy, and manage AI applications at scale, enhancing the impact of AI across your organization. 5. Deep Dream is a generative model that can generate surreal and psychedelic images from real-life images. It has been used in art and entertainment, producing some one-of-a-kind and visually stunning images. 6. StyleGAN is a generative model capable of producing high-quality images of faces that do not exist in reality. It's been used in a variety of applications, including creating realistic video game avatars and simulating human faces for medical research. 7. AlphaFold is a generative model that can predict protein structure. It has the potential to transform drug discovery and make it possible to develop more effective treatments for diseases. 8. Magenta is a Google project that creates music and art using generative AI. It has yielded some intriguing and impressive results, such as a piano duet performed by a human and an AI-generated piano. 9. Google AI's Palm 2 is a powerful LLM trained on a dataset 10 times larger. It excels in understanding nuances, generating coherent text and code, translating, and answering questions. Ongoing development promises to revolutionize human-computer interactions, enhancing accuracy, efficiency, creativity, and communication. 10. GitHub Copilot is an AI-powered coding assistant developed by OpenAI and GitHub that is designed to help developers write code more efficiently. It uses a deep learning algorithm to analyze code and generate suggestions for the developer, such as auto-completing code snippets or suggesting functions based on the context of the code. Generative AI is a rapidly evolving space and is expected to grow dramatically in the coming years. Though there are certain ethical concerns about generative AI, including potential misuse of AI-generated content and implications for intellectual property and copyright laws. In this video, you learned that generative AI enables applications to create, generate, and simulate new content. It leverages ML and deep learning techniques to learn patterns and generate original content. And some applications of Gen AI include GPT-4, ChatGPT, Bard, GitHub Copilot, and Palm 2.